Good morning. Today is going to be just a review day of 8.1 and 8.2 from the Big Ideas Algebra 2 book. We're going to be talking about rational functions, and in those rational functions, we're going to talk about domain, range, asymptotes, and go back a little bit and teach a little bit more about transformations. So first we're going to start with direct and inverse variation and neither, and how it relates to a table. So what we learned for direct variation is that y equals kx. But because we're looking at a table, we got to find the k value. So for direct, how do I get the k value by itself? Well, I divide by x. So y over x equals k is still direct variation. Inverse variation is y equals k over x. Now, to get the k by itself, I multiply by x. So if I multiply and get the same numbers, that's going to be an example of inverse. Okay? So it doesn't matter which we do first. We like multiplying first just because it seems to always be a little bit easier. Not that you have to. So instead of making a new table, I put k equals xy on top. And on the bottom, I do the y divided by x. So I'm going to start with the first numbers, okay? I have 2 and 18. When I multiply them, I get 36. The second numbers, when I multiply them, 3 times 12, I also get 36. And the last one, let's check it. When I multiply them, I have 4 and 9. So when I multiply 4 times 9, I get 36. Because the numbers were all the same when I multiplied, I have shown that this table is an example of inverse variation. So this is inverse. My k value is 36. So an inverse equation with the k value of 36 is 36 over x. Okay, and that is from 8.1. Then on 8.2, day 1, I kind of quickly went through transformations, maybe a little bit too fast, so I wanted to come back and talk about it again. I didn't do the B today, but I did do A, H, and K. A causes a stretch or a compression. If A is if A is greater than 0, it's a vertical stretch, which basically means these branches are actually stretching further away from the asymptotes. And if it's a vertical compression, that means the branches are getting closer to the asymptotes. Compression would be if A was a number between 0 and 1. Okay. H shifts left and right, but H is always the opposite of what you see since there's a minus sign, and K always goes up and down. So on these, I'm going to go ahead and write the first one, but I'm not going to write the other ones, but we will do them, okay? We have 3 things going on here that I can see off the bat. We have this negative sign. That means that A is a negative 1. So if A is a negative 1, that actually means this graph is reflected over the x-axis, which means that when I graph the asymptotes, that means the branches are actually in the second and fourth quadrants. H is this 4 right here, but it always changes sign, so it's not really a negative 4. H is actually a positive 4, so it's going to the right 4. And then this last number is going to be our k value. So k is a positive 10, which means this graph actually went up 10. Remember, these transformations are how they transformed from the parent function. Okay, so these next 2 questions, we're going to quickly do them, but I'm actually not going to write anything down. I'll just point to them. This 4 is a vertical stretch of 4. There is no h, so it doesn't go left or right at all. But this does make the graph go down 11, okay? This next one here, I see a couple things happening. Vertical stretch of 2. This is always the opposite of what you see, so this is really going left 5. Okay, now talking about asymptotes again, we have 2 different forms that we learned. On day 1, we talked about when there is no x on top and there's just a number. On day 2 video, we talked about the form when there is an x on the top or bottom. Okay, so we have a lot of questions. We're not going to do them all. Here's this first one. There is no x on top. Rule number 1 is always set your denominator equal to 0. my denominator is equal to 0. So my domain is all real numbers except x cannot be equal to 0. In this format, when there's no x on top, my range is the number that comes after it. Well, there is no number there. If there is no number, that actually means that my horizontal asymptote is y equals to 0. So my range is all real numbers except y cannot equal to 0. Okay. The second format we learned was this one. No matter what format it's in, we always take our denominator and set it equal to 0. Subtract 7 from both sides. Divide by 3. We get x equals negative 7/3, and that's actually my vertical asymptote. So my domain is all real numbers except x cannot be negative 7/3. So all real numbers, but x cannot be equal to negative 7/3. Remember, asymptotes are imaginary lines that the graph can never cross because we can't divide by 0. And when we have an x on the numerator and denominator, in order to get my horizontal asymptote, I divide my coefficients. So y is equal to 9 divided by 3. So we'll write that down. Y equals 9 over 3. So my horizontal asymptote is y equals 3. So my range is all real numbers except y cannot be equal to 3. Okay. Now, from a graph, how do we find all those numbers? We're going to do the same thing again, but this time we're going to put it in graph form, and we'll just do 2 questions, and that'll be all. So the first one, remember, when x is not on top, no matter what, rule number 1 is set your denominator equal to 0. Add 2 to both sides. We get x equals 2. Okay? That is a vertical line. So what I did this time is they're out of order. So where does that go? Well, that is a vertical asymptote at x is equal to 2. Well, which one is my vertical asymptote? Does it affect my domain or my range? It affects my domain. So my domain is all real numbers, except x cannot be equal to 2. My horizontal asymptote and range is going to be the number at the end here. That's just going to be y is equal to 1. So my horizontal asymptote is y equals 1. My range is all real numbers except y cannot equal to 1. So we're going to go ahead and graph that right here. Okay. And it's a positive graph because it is a positive 4 here, which means that my branches are going to be in the first and third quadrants. Okay. One more. 3x minus 6 equals 0. Add 6 to both sides, divide by 3, we got x equals to 2. Oh, by chance it's just the same numbers. Nothing special about that. Again, x equals 2 is a vertical asymptote. Okay. Which affects my domain. So my domain is all real numbers except x cannot equal to 2. My range is going to be the division of my coefficients. So 18 divided by 3. 18 divided by 3 is y equals 6. And we can barely fit it in there. Okay? And it's a positive, so my branches are going to go in the first and the third quadrants. My range, so y equals 6. All real numbers except y cannot equal to 6. And then we'll do one practice question again from 8.1. Given x and y, find the equation and also substitute other values back in there. Keyword here when you start reading it, the variables of x and y vary inversely. Whenever you see the term inversely, you should write y equals k over x. Okay? And we know that y equals 30 and x equals to 6. So our goal is to find out what k equals to. So how do I get rid of a divide by 6? I multiply by 6. Okay, 180 equals k. It's kind of a big number, no big deal. So we come back, we write an equation that relates these two. So 180 over x. Here's my part 1 because it's right the equation. But then this question actually did ask me as well, find y when x equals to 9. So find y, so y equals when x equals to 9. So 180 divided by 9, y equals to 20. So 2 parts of this question, and there are my 2 answers. Thank you for tuning in. Again, this was review of 8.1 and 8.2 from the Big Ideas Algebra 2 book. Subscribe to this channel. Hopefully this video helped you. Give it a thumbs up, and have a great day.